Hello everyone, and welcome to Jam Academy. In this example, we have a uniform chain. Remember, the chain is uniform. I'm going to come back to that later. A uniform chain of mass m and length L is stretched out on a rough horizontal table such that a portion partially hangs over the table as shown in the diagram below. If the chain starts slipping when the length of the hanging segment is L/3, we did show that in the previous problem, determine the work done by friction and the work done by the force of gravity as the chain falls vertically. Now, I'm going to assume that the portion of the hanging chain, the length of the hanging portion is X. Therefore, the length of the portion on the table is going to be L minus X. Now, also, the weight of the hanging portion acts through its center of mass. This is going to be mxg. Now, we have a couple of forces acting on the chain. You have the weight of the portion on the table. I'm going to call this m prime g. You have here friction acting to the left. I'm going to call this Fk, static friction. Now, we also have the tension along the chain. Now, we really don't care for the tension at the moment. All we have to do is calculate the work done by friction and the work done by the force of gravity as the chain falls. So if the chain is uniform, it means that the linear density of the chain is constant, and the linear density of the chain, lambda, is equal to the total mass of the chain divided by the total length of the chain. So this would mean that m over L, the linear density is constant, will be equal to mx divided by x. In other words, mx is equal to capital M over L multiplied by x. So this is the mass of the hanging portion. Similarly, we know that m over L will be equal to m prime divided by L minus x, which means that m prime will be equal to capital M over L bracket L minus x. So this is the mass of the table, this is the mass of the portion hanging on the tabletop. So let's calculate the force of gravity acting on the hanging portion. So Wx is just going to be equal to mxg, which is just going to be equal to capital M g over L multiplied by x. So this is the weight of the hanging portion. Now we will calculate the weight of the portion lying on the tabletop, which is just going to be equal to m prime g, which is equal to capital M g over L bracket L minus x. Now the good news is, when you look at the portion hanging, there is a normal force acting upwards, and we know that N is equal to the weight, which is just capital mg over L bracket L minus x. So this would mean that the kinetic friction acting on the chain is equal to mu, the normal force, which will be equal to mu capital Mg over L bracket L minus x. So right here we have the expression for the kinetic friction acting on the chain lying on the table. Now the next step is for us to calculate the work done by gravity and the work done by the friction force. So the work done by gravity will be equal to the integral. Remember that the chain starts slipping when this distance is L over 3. So the total work done by gravity will be equal to L over 3 to L, capital M X, all divided by L dx. Remember that the displacement is downwards, the force of gravity is downwards, so cosine theta is equal to 1. So this will be equal to M over L, the integral from L over 3 to L x dx, which is equal to M over L x squared over 2 from L over 3 to L. If you calculate this, your answer will be equal to 4 over 9 M. There's a G somewhere. Sorry, I omitted a G. This is mg over L. There's a G there. This is mg L squared. So this will give us the total work done by gravity on the falling chain. So let's calculate the total work done by friction. So W will be equal to the integral. We're integrating from, remember, that the total length of the chain on the tabletop is going to be 2L over 3. That's the length on the table when the chain starts slipping. So we will have here 2L over 3 to L. And that will be equal to mu capital Mg over L bracket L minus X dx. Now there is a negative sign here because the friction force is acting to the left, but the displacement is to the right. So cosine theta is equal to -1. And if that is the case, we have negative mu capital Mg over L, the integral from 2L over 3 to L bracket L minus X dx. This will be equal to negative mu capital Mg over L bracket Lx minus X squared over 2 from 2L over 3 right up to L. This will be equal to mu capital Mg over L bracket L squared minus 4L squared divided by 18. So this means that there's a negative sign here. Let's not forget. So this would imply that W will be equal to negative mu capital Mg over L bracket 18L squared minus 4L squared all divided by 18. 18 minus 4, that gives us 14. So this will be negative mu M negative 14. Let's not forget mu capital Mg L squared all divided by 18. So this is the total work done by the force of friction acting on the chain. Now, this is quite a problem. So please, if you have not understood any part of this problem, I will request that you participate in the discussion forum below this video so that we can actually help you. Thank you so much and have a wonderful day. Bye-bye.